Hey again, guys. So here is day 2 video. Hope everybody had an awesome 4-day weekend. So now we're actually going to talk about how to actually do the hypothesis test, but with your calculator. So Mrs. Wilkes may or may not do this activity with you. So it's how many hours did you sleep last night? It is kind of sad to see some of the numbers that you guys put down because I wish you'd get more sleep. Of course, who knows how much sleep I'm getting at this point when baby Baron is born, so I'm sure my numbers will be a little bit closer to yours. But right now, I'm getting like 8 to 9 hours of sleep, and it's a wonderful life. But on average, for age 13 to 18, they say that you need 9 hours of sleep. So whether or not you do this activity with Miss Wilkes or not, just keep that in mind. Okay, you guys need to sleep and make sure that you are getting your sleep each night. We could actually write the hypothesis test for this one together. So I'm going to do that just to get us nice and warmed up for our 2 examples that I'm going to do with you. So if you want to see if there's convincing evidence that students in statistics classes get less than the needed amount of sleep per night, that means our null hypothesis. So what we have to assume true is what I would love to assume is true for you guys is that your average hours of sleep is equal to 9. You are getting 9 hours of sleep. Remember, the reason why we're using mu and not X bar is because we are trying to say something about the population. Okay, we do take a sample, right? Your class, if you put your sample data down, that is us taking a sample, but it's to make a conclusion about the population. So the question is about the population. So I need you guys to remember that this is all about making a conclusion for our population. Our alternative for this example, so our HA, is that mu is less than 9 because we're trying to see if there's enough evidence, which you had to have me guess without seeing any data at all. I guess that it's probably true, okay? So if you guys do this, remember that you're going to have conditions to check. That's going to be our next video that we'll have for tomorrow's lesson. Remember that the alpha that we always compare our p-values to, so when you do your calculations, you're going to get some test statistic, and a p-value. My guess is that p-value is probably going to be pretty close to 0 since a lot of you are not very good with your sleep. And we're going to compare that to alpha. Remember that alpha is equal to 0.05. So to get that test statistic and the p-value, we're going to use these calculator steps, which I'll show you. We have 2 examples that I'm doing today in the videos. So to show you really quickly where that's at, so in my calculator, I would go to stat. So stat is one of our buttons. And then we arrow over to test. You should be very, very familiar with this menu since we've done it for the past 3 units. We did it for confidence intervals with proportions, hypothesis testing with proportions, and confidence intervals with means. So now we're just doing hypothesis testing with means. So we're going to pick a t-test, not anything with z, right? It makes no sense to go back to one proportion z test. Okay, we're using our t-test now, option 2. Just like last time or all the other times, you're going to have data and statistics. So you guys would have had data for your class. Right now, I have no data typed in. So remember, the way you type in data is stat edit. Oh, I guess I do have some data typed in. This is definitely not for hours of sleep, though. It's whatever last problem we were doing when I was still here. But you would type in the entire class's data into L1. We're not going to separate it by male or female yet. Okay. Then you do your stat test, option number 2 for t-test. You have your data. Our null hypothesis was 9, and we wanted to see if there's convincing evidence to show less than. And then you'd go to calculator draw, just depending if you need help with the shading, because sometimes shading this curve, guys, is worth points. So if you need help, hit draw, and I'll show you exactly where the shading should be. If you don't need help, it's faster just to hit calculate. And then, of course, you'd make your conclusion, which, remember, is always going to be 2 sentences, which you'll see on the next page with me when we do our examples that everybody can have, regardless of what data is used. So you'll always compare the p-value to alpha and whether you reject or fail to reject the null hypothesis. And then you will also tell me whether you have sufficient evidence or insufficient evidence to prove the alternative. So let me show you that in action. So the first one we're going to talk about is, are women marrying at a later age? So a report stated in 2000, based on census data, the mean age of brides marrying for the first time was 25 years. In 2016, a random sample of 100 brides had a mean of 27.5 years with a standard deviation of 5.6 years. And they want to know, is there sufficient evidence to support the claim that women are marrying at a later age? So first thing you always start with is writing your hypotheses. So my null hypothesis is that the mean age to marry is 25. We're just going to assume that to be true. The alternative is that the mean is greater than 25. And that's because they said a later age. If I say a later age, that means it's going to happen after 25. For your calculations, we need our t-test statistic and our p-value. This time we don't have data, we have stats. So just to remind you, in that same menu I was just talking about, if I go to stat, test, and then t-test, if I go to stats, this reminds you everything you need. So we need our null hypothesis, which is 25. We need X bar, which is our sample mean. So X bar said we had a mean of 27.5 years. So I'm going to type in 27.5. The standard deviation they give us, so our S is 5.6 years. So I type that in. And then our sample size was 100 brides. And our alternative that we're trying to show is that it's greater than. So once again, I'll show you one with draw, one with calculate. If you hit draw, it will draw that curve for you. And I have to turn some stuff off from when I was doing some box plot work. So let's do that again. If I hit draw, it's going to show you how that curve should be shaded in case they have that be points. So if they ever tell you to shade and label the curve, we'll have our curve here. And it's going to show us where the shading is at. Super little because we get a t-score of 4.464. And then we're shading above that. And that's why you don't really see any shading on this curve, because it's so far away and it's so flat. And notice how my p-value is 0. So I got a t-test statistic of 4.464 and a p-value of 0. So my conclusion would be that since the p-value is less than or equal to alpha, which is 0.05, we are going to reject the null hypothesis. Okay? What this means is that we do have sufficient evidence. We have sufficient evidence to support the claim that women are marrying at a later age. And remember, if you're able to reject HO, that means that it's statistically significant. You don't have to say that in your conclusion, but you should be keeping that in your back of your mind. If you can reject the null hypothesis, you have found a statistically significant result. Okay, so I'm going to pause this video and we'll do one more with data. But let's see my time, CMA 52. Say, hi guys, see me there in the corner? Okay, so I'll show you the next example in the next video. See you guys soon.